Okay, so on pages 54 and 55, we're just going to review composition of functions. And so in the top box on page 54, I'm just going to start doing what it asked me to do. So number 1 wants me to find g of 4. And right above the box, it says that g of x is equal to x squared plus 2. So if I want to find g of 4, you would tell me that I'm going to plug in 4. Please make sure you plug it in with parentheses so we can take care of our negatives and we don't have an issue on the back end. And so now you can now calculate that g of 4 equals 16 plus 2, which is equal to 18. The second one wants me to find f of 18, which is going to be 2 times 18 minus 3. Please note that I'm using the function for f that they gave me, which is 2x minus 3. Okay, so this is a little bit trickier. Number 3 says that it wants you to do f of g of 4, and it says f of blank. Well, if you look at this inside piece right here, g of 4, I'm going to draw a line across all of my work. We already know that g of 4 right here is 18, so I'm going to plug in an 18 right here. And f of 18, we found right here, f of 18 was equal to, oh, I told you 33 earlier, I only wrote 3, was equal to 33. So now we know that f of g of 4 equals 33. Now on the right-hand side of the box, we're going to do a couple more problems. So on the right-hand side of the box, number 1 says find f of g of x, which is the same thing as saying find f of x squared plus 2, which means in my f function, f of x equals 2x minus 3, I am going to plug in x squared plus 2 for every x that I see. So I'm now going to get f of x squared plus 2 equals 2 times x squared plus 2 minus 3. I'm going to do a little bit of cleaning up in algebra. 2x squared plus 4 minus 3. Final answer is 2x squared, plus 1. And the last one, you find f of g of 4, which we have exhausted many times now. We know that that is 33, because we know that g of 4 is 18, f of 18 we have said is 33. So then in the middle of the page it says composition, which sometimes you have been taught is fog and goff, but we're going to call it by the proper name, f of g of x and g of f of x. And it says something very important in the middle of the page. It says that the domain of f of g of x consists of those x that are in the domain of g for which g is in the domain of f. So what that's really saying is that if the number doesn't belong in g or f to begin with, if it's not in their domains, it cannot be in the domain when you put the two functions together in composition. So we're going to do number 1 and 2 in the second box. Okay, so now we're going to do this middle box on page 54. So I have two functions, f and g. And first it says, what is the domain of f? Well, f of x in our case is 2x plus 1. And that's a line, so you should know that its domain is negative infinity to infinity. And then it says, what's the domain of g? G of x is equal to the square root of x. And that's a parent function, so you should also know that its domain is from 0 to infinity. We can square root 0, but we can't square root a negative. Well, technically we can, but we don't really want our friend I to come back quite yet. So the number 1 says compute f of g and find its domain. So number 1, f of g of x equals f of the square root of x equals 2 square root of x plus 1. Well, if you think about where the domains right here overlap, it's only from 0 to infinity. And so my domain for my new function here is going to be from 0 to infinity. Number 2 wants you to compute g of f of x. So g of 2x plus 1. And so that's going to get me the square root of 2x plus 1. This domain's a little bit trickier because even though f was defined for all real numbers, when you plug it into g, that's not the case anymore. If you remember your implied domain rules, we cannot square root a negative, so 2x plus 1 has to be greater than or equal to 0. Subtract the 1 over, and divide by 2. X has to be greater than or equal to negative 1/2. So my domain for this one is negative 1/2 to infinity. However, if you look right here, I'm going to use blue, compare this to this right here, the domain. We can't add in the negative 1/2 because it wasn't in g to start with. So in fact, the correct answer here would be that this has to be a 0, from 0 to infinity. Because just because we plug something else in doesn't mean we can get more values out if it didn't exist in the first place. Okay, so now on page 55, we are going to practice finding compositions f of g, g of f, and g of g. So what I want you to do is I want you to pause the video. I want you to find all three and their domains, and then I want you to come back and make sure that what you got is the right answer. Okay, so if we look at letter A, I'm just going to use my pen and kind of walk you along. So I've plugged in the function, so I get right here. I multiplied my 5 times my 1 over x and got this. I changed my 1 to an x over x because x over x is 1, and that got me common denominator. So now instead of having a whole number and a fraction in the denominator, I can make it one fraction like I did right here. And then dividing fractions is as easy as pi. Flip the second and multiply. So I flipped over my fraction and multiplied, so you get 4x over x minus 5. And then when you look at the domains for the separate pieces, in f, x can't be 1/5. And in g, x cannot equal 0. And in our case right here, x cannot equal 5. So we can't be 0, we can't be 5, or we can't be 1/5. So that is your domain. Negative infinity to 0, 0 to 1/5, 1/5 to 5, and 5 to infinity. Okay, so when I did g of f of x, I'm going to plug in my f into g. And when I do that, I get this. And then I'm dividing by a fraction so I can flip and multiply like this right here. And then I get this red box thing, or you can separate it and divide each piece by 1/4. So what you really have is 1/4 minus 5 over 4x, which you know is a linear function with a y-intercept of 1/4 and a slope of negative 4/5. Sorry, negative 5/4. So again, my f function can't be 5, my g function can't be 0, but I made a line. So this line is defined from negative infinity to 0, 0 to 1/5, 1/5 to infinity, because you can't plug something in that didn't exist in the first place. So I hope you kind of get the gist of this. I'm going to skip the second letter B for the interest of time and the interest of not being able to number, and we're going to go to number 15. So number 15, 16, 17, 18 are a little bit tricky. What we want to do is we want to decompose H into F and G. So let me break this down for you as easy as I can. Number 15 says that I have h of x equals 3x squared minus 2 to the 4th. The easiest way for me to look at this, and I hope that it helps you, is that I have something, math stuff, garbage, crap, whatever you want to call it, I have something to the 4th power. So here is what I want to do. First of all, I need to take note that I'm doing f of g of x. So the outside function is going to get the power, and the inside function is going to be the stuff. So right now my stuff is going to become g. So if I do g of x equals 3x squared minus 2, and I say that f of x equals x to the 4th, when you take g and you plug it in for this x, you will end up getting back to stuff to the 4th power. So these two things that I just underlined, those are your answers. That's the decomposed function. If we try number 16, it's the same idea. You have stuff raised to the 8th power. So if I want to decompose this stuff, I think the best bet is that you call f of x, x to the 8th, because you have something to the 8th power. And g of x should be that something, that stuff that you need to raise to the 8th power, so which we're going to call x squared minus x plus 1. Pause the video, and I want you to try 17 and 19. Apparently, I really struggled on page 55 about numbering and lettering things, and I apologize. You try 17 and 19 and then restart the video again. So for 17, you have something cubed rooted, so I'm going to call f of x the cubed root of x, and g of x is going to be x minus 4. So that when you plug this in, the x minus 4 end up being under the radical, and you'll get the cubed root of x minus 4. And then for number 19, just because it's a fraction doesn't mean it's scary. F of x is going to equal 1 over x, or 1 over something, and g of x is that something, which I need x to become x plus 2. So when you plug this in right here, you will get back to your h of x, which was 1 over x minus 2. See, not so bad. Happy math. Hope this helps you out. Make sure that you have pages 56, 57 done for Tuesday. And yes, when I am back on Monday, I am checking all of your notes, so make sure they are done.